In this video, we're going to talk about all the trigonometric functions that we didn't talk about in 5.2. So if you remember in 5.2, we talked about sine and cosine. Now in 5.3, we're going to talk about tangent, cotangent, secant, and cosecant. So we write these as follows. So tangent we write as tan of theta, cotangent we write as COT of theta, secant is SEC of theta, and cosecant is CSC of theta. Excuse me. So when we solve these other four trigonometric functions, we use what are called identities. So identities are basically formulas that help us to solve things in different ways. That's the way we want to think about it right now. So the first couple of identities that we're going to talk about are what we call the quotient identities. So these are in terms of tangent and cotangent, and what we do is we're able to write tangent and cotangent in terms of sine and cosine. This is really nice because in the previous section we talked about values for sine and cosine, so we can use those to help us get tangent and cotangent. So tangent of theta we can just say is sine of theta divided by cosine of theta, and cotangent we can say is cosine of theta divided by sine of theta. Okay? Now, another type of identity that becomes really important are the Pythagorean identities. So the reason we call these Pythagorean is they remind us of the Pythagorean theorem, which is a squared plus b squared is equal to c squared, that we use for right triangles. So this first one that I have written here, sine squared of theta plus cosine squared of theta equals 1, you might remember is that equation from the previous video where I said we weren't going to talk about it very much in 5.2, but in 5.3 it would become important. So this came from the unit circle. Okay, now we actually have two other Pythagorean identities which we can get by manipulating this first equation. So first of all, we can have 1 plus cotangent squared of theta is equal to cosecant squared of theta. And we could also have tangent squared of theta plus 1 is equal to secant squared of theta. So I think it's really important that when we start listing all of these formulas, it's important to see how they connect to each other. So if we look at the first equation compared to the second equation, you might notice that we can get from number 1 to number 2 by dividing number 1 by sine squared of theta. And likewise, we can get from number 1 to number 3 by dividing number 1 by cosine squared of theta. So we just take every term in the first equation and we divide by either sine squared of theta or cosine squared of theta, and we end up with equations 2 and 3. So me personally, I don't actually remember all three of these. I just remember the first one and I remember how to get to the other two. So that's less for you to remember. Now, it might be important to point out that when we write a trig function like this with an exponent right after the name of the function, what we're actually saying here is we're taking the value of that trig function and we're applying the exponent. So it's just a shorter way to write raising a trig function to an exponent without parentheses. So you'll see that very often. So this would be the same thing as if we had, I don't know, cosecant squared of theta. This would be cosecant of theta, and we would take that whole value and square it. Okay, so just get used to writing your exponents like that when it comes to trig functions. Another type of identity that becomes very important are what we call reciprocal identities. So cosecant, secant, and cotangent are actually just related to sine, cosine, and tangent. So cosecant of theta is actually just 1 divided by the sine of theta. Secant of theta is 1 divided by cosine of theta. And cotangent is just 1 divided by tangent of theta. So our whole goal with these is to take these trig functions that we may have not seen before and relate it back to something that we do know. So like cosecant and secant, we want to relate it back to sine and cosine. Cotangent, we're relating to tangent, but remember that way up here, we related tangent back to sine and cosine. So we're trying to get everything back into sine and cosine because we know values for those functions. Okay, so that's the idea. So we're going to practice. We're going to find the exact value. So remember, exact value is a specific set of directions of the trigonometric function at the given real number. So we're going to practice first with something we did in 5.2. We're going to find the sine of 5 pi over 6. So maybe let's still draw our picture out. So eventually when you're doing these, you may not need to draw the pictures, but I would suggest doing it when you first start out just to make sure your angles are in the correct place. So if you remember, we have 0. If we're talking about pi over 6 angles, we think of the top as 3 pi over 6, and we think of this as 6 pi over 6. So 5 pi over 6 must fall about right there. Okay, so what we can see from this angle is that the sine of 5 pi over 6 is really just going to be the sine of pi over 6, which is equal to 1/2. Okay, now when we go to part B and we want to find the cosecant of 5 pi over 6, well, we can just use an identity and use our answer from part A. So cosecant is 1 divided by the sine of 5 pi over 6. And so we can sub in that value for the sine of 5 pi over 6. That's just 1/2. So 1 divided by 1/2 just gives us 2. So the cosecant of 5 pi over 6 is just 2. All right. Another type of identity that we're going to mention are what we call even and odd identities. So you may have talked about even and odd functions in the past, maybe not. Basically, the idea with these is when you plug in a negative number to the function, we want to describe what happens to the negative sign. So in an even function, when you plug in a negative number, basically the negative sign just disappears. In an odd function, when you plug in a negative number, the negative sign can be pulled out to the front of the function. Okay, that's the basic idea. So certain trigonometric functions are even and certain ones are odd. So the even functions are cosine and secant because it's related to cosine. So we have cosine of negative x is equal to just the cosine of x. So when you plug in a negative number to cosine, it's the same as if you just plugged in the positive number. And then secant is the same thing. So secant of negative x is equal to secant of x. Now our odd functions are going to be all the remaining trigonometric functions. So first we have sine of negative x is equal to negative sine of x. So all that means is if we plug in a negative number to sine, the negative sign can be pulled out front. So since sine is odd, cosecant must also be odd because, well, it's just 1 over sine. So cosecant of negative x is negative cosecant of x. And then tangent is also odd. So we have tangent of negative x is equal to negative tangent of x. And finally, cotangent of negative x is equal to negative cotangent of x. And so cotangent is just because it's the reciprocal of tangent. Okay, so those are our even and odd functions. So now we're going to practice using a couple of these to evaluate some more expressions. So our first example is the tangent of negative pi over 4. So the first thing we can do here is we know that tangent is an odd function. So since we plugged in negative pi over 4, we can take that negative sign and bring it out to the front. So this is the same as the negative tangent of pi over 4. So now that we've pulled that negative sign out front, we need to figure out how can we rewrite tangent in a way that we can actually evaluate it. So tangent, if you remember from our quotient identities, is just sine over cosine. So we have the sine of pi over 4 divided by the cosine of pi over 4. Okay, and now that we have tangent back into sine and cosine, we can use values from the unit circle that we learned in 5.2. So hopefully you've been studying those. So the sine of pi over 4 is square root of 2 over 2. And the cosine of pi over 4 is also square root of 2 over 2. So when we divide a number by itself, that's just going to give us 1. So the tangent of negative pi over 4 is just negative 1. So notice what we did here. First, we used an even-odd identity to pull the negative sign out to the front, and then we used a second identity, the quotient identity, to get those values of sine and cosine, so we could actually evaluate our function. Okay, so just because the problem says to use even and odd identities, you may have to use a second step in there in some other identity. So you just have to pay attention to what the problem is asking. Okay, in our next example, we have cosecant of negative 7 pi over 6. So cosecant was also an odd function. So the first thing we can do is take the negative sign and write it out front. So we have negative cosecant of 7 pi divided by 6. And now we can use a second identity. So remember that cosecant is just 1 over sine. So we can say that this is the same thing as negative 1 divided by the sine of 7 pi over 6. And now we're back to a problem just like in 5.2. So our problem has come down to, well, what is the sine of 7 pi over 6? And if you remember, that comes out to be negative 1/2. So we could go through the whole, like, draw the picture, figure out where 7 pi over 6 is, find the reference angle. But as you keep doing these, you should eventually start to be able to skip those steps and jump straight to negative 1/2. Okay? And so finally, if we do this division, we'll have negative times negative 2. So if we do the division of 1 over negative 1/2, we'll get negative 2, but we still have that negative out front. So our final answer is just going to be a positive 2. Okay, so once again, first we used the even and odd identities, but then there was a second step in there where we had to realize that we had to use a different kind of identity to fully solve the problem. Okay, so that happens quite a bit. Okay, so the next thing we're going to talk about is similar to when we did sine and cosine. We talked about that in different quadrants, sine and cosine have different signs. So in certain quadrants they're positive, and in certain quadrants they're negative. So it shouldn't be a surprise that tangent, secant, cosecant, and cotangent are exactly the same way, because they all relate back to those initial sine and cosine functions that we talked about. So this chart here summarizes which functions are positive in which quadrant. So I'll just write a little note of that. So these are where functions are positive. So if a function is not listed in a quadrant, that means that it's negative in that quadrant. Okay. And that's just to cut down on how much is written in the picture. So maybe let's talk about why these are true. So sine and cosine were pretty easy to see, right? Because they just relate back to the x and y coordinates of the points in that particular quadrant. So maybe let's remind ourselves, quadrant 1 is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. So to think about why these statements in this picture are true, I'm going to run through an example with tangent. Okay, so let's think about tangent of theta. And we know from our quotient identities that this is sine of theta divided by cosine of theta. Okay, so first of all, I'm going to think about what happens to tangent in quadrant 1. Okay, so tangent of theta would be a positive number divided by a positive number. So in quadrant 1, we know that sine is positive as well as cosine. So tangent is just going to be a positive number divided by a positive number, which gives us a positive number. And so notice in our diagram, we see tangent is listed in quadrant 1, which means that it's positive. In quadrant 2, tangent of theta is going to be a positive number divided by a negative number. So sine is positive, cosine is negative, so our division works this way, which gives us a negative number. And if we notice in our diagram, tangent is not listed for quadrant 2, which says that it should be negative. In quadrant 3, tangent is going to be a negative number divided by a negative number, which gives us a positive number. And if we go and look at tangent 3, well, look, we see tangent is listed, so that's good. That means it's positive. And finally, in quadrant 4, tangent of theta is going to be a negative number divided by a positive number, which gives us a negative number. And if we go and look at our diagram, we see that tangent is not listed, so it is indeed negative. Okay, so this is basically how you would want to think through all 4 of the trigonometric functions in this section. So you want to go through each quadrant and think about what identity that relates it back to sine and cosine can tell me what happens to the sign in that quadrant. So I think going through the other 3 functions yourself is a good exercise to help you remember how this works. Okay, so it's one thing to just remember this chart, but I think if you understand why it works, you remember it a lot easier than just trying to shove it in your brain. So as an exercise, so you can do yourself. So go through this idea for secant of theta, cosecant of theta, and cotangent of theta. So again, that's not a homework problem, but it's a good idea just while you're doing your homework, take like 5 or 10 minutes and just go through those 3 other functions. And I really think it would be beneficial. So that's something you can do in your own time. Okay, so our next examples, we're going to just practice finding some more exact values. So in our first example, we have tangent of negative 13 pi over 6. So let's think about where that is. So on our unit circle, 13 pi over 6 is going to be 1 pi over 6. Oh, right. Okay. I know what I want to do here. Okay, so we have a negative first. So first of all, we know tangent is an odd function, so we can pull the negative out front. So this is negative tangent of 13 pi over 6. Now we want to think about where is the angle of positive 13 pi over 6. Okay, so now we're going to go back to the picture I was drawing before. So 13 pi over 6 is 1 pi over 6 more than 12 pi over 6, which is 2 pi. So maybe instead of labeling all the quadrants, maybe we can get to the point now where we can just say 13 pi over 6 should fall right there. So it's actually in the same position as our normal angle of pi over 6. Okay, so what we can say is this is the same thing as the negative tangent of pi over 6, and we can break this down into sine and cosine. We can say that this is negative sine of pi over 6 divided by cosine of pi over 6, which is negative 1/2 divided by the square root of 3 over 2. So those values just come from the unit circle. And then we can divide those fractions. So we can say this is negative 1/2 times 2 over the square root of 3. So remember, when you divide fractions, you take the bottom fraction, flip it, and multiply by the top fraction. So we can just say that this is negative 1 over the square root of 3. And so that is our final answer. So just another reminder, we wanted to find an exact value, so I want your answer in this form with the fractions, with the square roots. I should not see a decimal. Okay? Our next example is the cosecant of 5 pi over 3. So first of all, let's think about where 5 pi over 3 is. So if we draw our quadrants, 5 pi over 3 should be somewhere in the fourth quadrant because we know that 2 pi is 6 pi over 3. And so 5 pi over 3 would be a single pi over 3 less than that. So 5 pi over 3 would be down here. Okay, so the first thing we can do is we know that cosecant is the same as 1 divided by the sine of 5 pi over 3. So our problem becomes, well, what is the sine of 5 pi over 3? So we know that this is just going to be the sine of pi over 3, but in the fourth quadrant, so it's going to be the negative. So the sine of pi over 3 is square root of 3 over 2, but we're going to make that negative. So when we divide these, we're just going to get negative 2 divided by the square root of 3. So this would be the cosecant of 5 pi over 3. And then in our final example, we're going to think about a problem in degrees since we've been doing everything in radians. So our final example with this type of example is the secant of 300 degrees. So the first thing we can do is we know that secant is the reciprocal of cosine, so we can turn our problem into 1 divided by the cosine of 300 degrees. Okay, so now to make it easier to think about as far as our unit circle goes, maybe we can convert 300 degrees into radians. So 300 degrees is going to fall right here. And actually, that's exactly the same as the picture we just drew up here. So if we think about this is 60 degrees from 360. Well, it's like we're counting pi over 3 backwards from 2 pi. So 300 degrees is actually just the degree form of 5 pi over 3. So it's the angle we were just talking about. So we can say that this is 1 over the cosine of 5 pi over 3. And so the cosine of 5 pi over 3 is just 1/2. So we have 1 divided by 1/2, which if we carry out the division gives us 2. So 2 is the secant of 300 degrees. Okay, so now that we've talked about finding values of secant, cosecant, tangent, and cotangent, we're going to tie this all together in the following example. So now, kind of like at the end of 5.2 when we were given a sine and we found a cosine, in this example, we're given a value of cosine, so we know cosine of t is 7 over 8, and we know that our angle t is in quadrant 4. So these are our two pieces of information. And using those pieces of information, we want to find all 6 trig values for the angle t. Okay, so just a reminder, maybe we can write a table over in the corner of all of our trig functions so that we don't forget any. So we have sine of t, cosine of t, tangent of t, cosecant of t, secant of t, and cotangent of t. So you'll notice I've organized this table where I put the reciprocals across from each other, and I tend to do that because it just helps me remember like what's the reciprocal of each function. So normally when I write a table of trig functions, you'll see me do it in this exact same order every single time. Okay, so let's write down what we already know. We already know cosine of t, so that's a freebie. That's 7 over 8. And since we know cosine of t, we can get secant of t right away. So secant of t is just going to be if we flip the cosine of t. So secant of t is going to be 8 over 7. And now we need to think about how can we find every other trig function. Okay, so first of all, let's think about what the quadrant tells us. So quadrant 4 tells us that cosine is positive, so cosine of t is positive and sine of t is negative. Okay, we already knew that cosine of t was positive because we were given a positive number. but quadrant 4 also tells us that the y-coordinate should be negative. So when we find the sign of t, we need to pick the negative value. So to do this, we're going to use that unit circle equation that we did in 5.2, but we're going to write it in the form that we've now learned in 5.3 of that Pythagorean identity. So we're going to write cosine squared of t plus sine squared of t is equal to 1. Okay, so we're going to plug in the value we know. We know 7 over 8 is the value of cosine, so 7 over 8 squared plus sine squared of t is equal to 1. If I square 7 over 8, I'm going to get 49 over 64 plus sine squared of t is equal to 1. So sine squared of t is equal to 64 over 64 minus 49 over 64, which if I do that subtraction, I should get 15 over 64. And that's still sine squared of t. So now I can take the square root of both sides. So I write sine of t is equal to the negative square root of 15 over 64. So the reason I wrote the negative is because I know that sine is going to be negative from this information that I had about quadrant 4 up at the top. Okay? And finally, I can just rewrite this as negative square root of 15 divided by 8. So 64 is a perfect square, so I can go ahead and rewrite that with its square root. Okay, so I have a value for the sine of t. It's negative square root of 15 divided by 8. So then I can jump straight to cosecant of t because it's the reciprocal. So I can just say cosecant of t is negative 8 divided by the square root of 15. So now I have 4 of the 6 trig functions, and I still need to get tangent and cotangent. So for tangent of t, I can use my quotient identity of sine t divided by cosine of t. So we just found that sine of t is negative square root of 15 divided by 8, and we already knew cosine of t was 7 over 8. So if I divide these two fractions, I flip the second one and multiply, and so these 8's are going to cancel, and I'm left with tangent of t is negative square root of 15 divided by 7. So I can go ahead and write that in the box. So tangent of t is negative square root of 15 divided by 7. And right then I can jump to cotangent of t because it's the reciprocal of tangent. And I can say cotangent of t is negative 7 over the square root of 15. Okay, so when we come to a test, it's really important that you show your work. So maybe here is a good point to stop and talk about all the work that we need to show for this problem. So notice first, I didn't need to show work for cosine of t because it was given. And I feel like the reciprocal functions are simple enough where it's not necessary to really show your work. So all we're doing is flipping the fractions of sine, cosine, and tangent, so I really don't care that you show work for those. Of course, you're always welcome to, but you don't have to. It's mostly important that you show this work here for sine of t, so I want to see you solve that equation, and also tangent of t, I want to see that you can use sine and cosine to get that value for tangent, okay? So what we showed here is the important stuff that you need to show, and of course it's always nice to see your answers organized in a table like this, okay? That's just a good practice too, because like I said, it'll solidify what's actually the reciprocal of sine, cosine, and tangent, okay? So just be mindful of that when you're working through your homework. Even though WebAssign doesn't really care about what work you show, it's a good idea to practice that, because on a test, that's the only thing I'm going to be grading is the work that you show, more so than your answer. Okay? So the final thing we're going to do in 5.3, just like 5.2, is just briefly talk about how we use a calculator to evaluate these functions. So this is where the reciprocal identities become very important, because calculators do not have buttons for secant, cosecant, and cotangent. So you're going to have to use the identities first. So it's so important, I'm going to write that down. So you must use identities first before you ever type something in the calculator. Okay? So, and also just remember whether you need to be in degree mode or radian mode, depending on the problem. So this first problem, we're going to be in radian mode because we have the secant of pi over 10. So pi over 10 is in radians, so our calculator also needs to be in radians. So the first thing to notice is that secant is the reciprocal of cosine, so we can rewrite this problem as 1 over the cosine of pi over 10. So the way you would type this into your calculator is 1 divided by cosine of pi divided by 10. So just make sure that the fraction inside the cosine is in a set of parentheses so that your calculator knows to keep all of that together. And just be careful with the division sign there. So this is sort of the way you would type it in. If your calculator is one of those backwards ones where you have to type a fraction before hitting cosine, you would type this in as like pi over 10, then hit cosine, and then do 1 divided by answer. So it's a little bit more complicated. So if you have one of those calculators where you type things in a little backwards, you may want to talk to me in office hours or ask me questions during class time. Okay? But the point is, if you were to type this into the calculator, you should get 1.051 if we're rounding to 3 decimal places. So again, make sure to punch that into whatever calculator you're going to use, and make sure that you get the same answer. Okay, and then part B, we need to be in degree mode. So notice that our angle is 33 degrees. So that tells us we need to put our calculator into degree mode. And now we can say that cotangent is the reciprocal of tangent, so I can rewrite my problem as 1 over tangent of 33 degrees. And so now my calculator has a tangent button. So I can type this in as 1 divided by tangent of 33. Or if your calculator, again, is one of the backwards ones, you would need to do 33, then hit tangent, then do 1 divided by answer. Okay? And if you punch that in, either way, you should get 1.540 if we're rounding to 3 decimal places. So again, just make sure to practice these in your calculator because I can't really show you that on a video lecture. So make sure as you're working through these notes that you have your calculator out and you're trying to do these buttons as I'm walking you through them. Okay, so that concludes 5.3.